In the last video, I talked about taking the transformation of the derivative. This time I want to do the opposite. I want to take the derivative of the transform. Once again, let's denote the transform by capital F of S. Then I want to know what's the derivative with respect to S of capital F of S. So let's think this through. We need the derivative of the transform, which is the integral from 0 to infinity, e to the minus st f of t dt. Since this derivative is not with respect to t, it's with respect to s, and my integral is with respect to t, I can move it inside the integral. So I have the integral from 0 to infinity of dds e to the minus st f of t dt. The only term that depends on s is this e to the minus st. So my derivative would be negative t e to the minus st times f of t. Well, this is negative times the transform of t f of t. So now I can talk about taking the derivative of the transform. I get negative transform of t f of t. And in general, this can be expanded. The transform of t to the n f of t, each one of these will constitute a new negative sign, so we have negative 1 to the n, times the nth derivative of f of s with respect to s. So let's look at some examples on how we might want to use this. Let's try to find the transform of t times sine bt. Since we have t to the first power, this is going to be negative times the derivative of the transform of sine bt. We've discussed in previous videos that the transform of sine of bt is b over s squared plus b squared. Well, we see that this is a quotient, so when we take the derivative, I'm going to have this negative floating around. The derivative of the top is 0 times the bottom minus the top times the derivative of the bottom, which will be 2s, all over the bottom squared. So this whole term here goes to 0. I have a double negative, so that makes me positive again. And I have positive 2bs over s squared plus b squared squared. So now I can have my original set of transforms as well as all of those transforms times any power of t. Let's look at one more. Let's consider this one. We know the transform of e to the at is 1 over s minus a, and I want to find the transform of t e to the at. Well, my rule says that if I multiply by a power of t, I do negative 1 to that power, so negative 1 to the first power, times the nth derivative, so the first derivative of the transform of e to the at. Well, if I take the derivative of this with respect to s, we have the derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. This will go to 0, and I have a double negative, so that makes me positive 1 over s minus a squared.